In this video, we're going to discuss the greenhouse effect. So in general, the greenhouse effect is a natural energy trapping process. There's a little bit of a negative connotation around the greenhouse effect, but it's important to keep in mind that we're going to differentiate between the natural greenhouse effect and then what we're going to call the anthropogenic greenhouse effect. So when gases are in our atmosphere absorb infrared radiation, some of them radiate some of it back into our planet to keep us warm, and then the rest goes out into space. We've talked about this kind of idea in a previous video. This is a very delicate balance, however, and it helps ensure that life on our planet can thrive. Where issues arise is when the chemicals in our atmosphere are kind of thrown out of balance. And it becomes a big problem when this is human produced. So a lot of human produced greenhouse gases are causing this imbalance in the atmosphere. This is known as the anthropogenic or man-made greenhouse effect. So what are some ways that humans are contributing to greenhouse gases in the atmosphere? We talk a lot about carbon dioxide. So anything that produces carbon dioxide is kind of your first guess. So vehicles, pollution, industrialization are two big factors of producing carbon dioxide. There is also a natural balance of things on our planet that help remove CO2. And trees and large forests are a big example of that. So the deforestation, the cutting down of trees actually is a way that the greenhouse effect is amplified, because removing those trees from our environment does not allow them to remove carbon dioxide from our atmosphere. So this is also known as the enhanced greenhouse effect, because what's happening is the natural greenhouse effect that is supposed to exist on our planet is being amplified by human contributions. This graph here is what's known as a Keeling curve, and it is just showing us the seasonal variations in carbon dioxide, but then how they've also changed over time. So if we're to take a snapshot of any given year, January to December, what we see is this increase and decrease of CO2 levels over the course of a year, and that is expected. Plant photosynthesis in the summer increases, which means carbon dioxide levels go down, and plant photosynthesis in the winter decreases, which means carbon dioxide levels go up. That part is expected. The part that is less expected, of course, or the part that is harming our planet more, is how this cycle actually increases year over year. So the maximums tends to increase and the minimums go up as well. So if you look at kind of our neighboring planets, for example, right? What planet is cold due to a lack of CO2 in the atmosphere, and what planet demonstrates an abundance of it? Well, Mars is cold. And then Venus is, of course, a little bit hotter. And that has to do partially to the atmospheric abundance of CO2 and other gases on those planets. So why is carbon dioxide of concern compared to something like water vapor? Water vapor also does a good job of absorbing radiation from the sun, but the problem with something like carbon dioxide is that it has a longer permanence. It exists much longer in our atmosphere, averaging about 100 years. So it's tougher to break down that carbon dioxide. We can see this traditional, we call like a hockey stick curve, where the concentration of carbon dioxide has remained steady for hundreds of years, thousands of years in some cases. And the introduction of the Industrial Revolution caused a dramatic shift, and that's where we kind of get that hockey stick kind of shape from. There are always cyclical changes in carbon dioxide. Every time there is an ice age, which we kind of get every 100,000 years or so, we get a jump and then a decrease in CO2 levels. The issue is that the one we're currently in right now is a much higher jump than we've ever seen before in recorded history. So there are some common greenhouse gases. Carbon dioxide is the most obvious one. We get carbon dioxide from burning fossil fuels for transportation, heating, electricity, and industry. And then we, by encouraging deforestation are not allowing a planet to naturally remove carbon dioxide from the atmosphere. It is the most abundant greenhouse gas, and it is also therefore the most important to control, and it can last hundreds of years in the atmosphere. We have kind of natural land formations that we call carbon sinks. So those are large forests or large bodies of water where carbon dioxide can be trapped. So it's important to keep those healthy so that they can continue to do their job and remove carbon dioxide from the atmosphere. Methane is another common greenhouse gas. It's present in the atmosphere in much smaller quantities than CO2. It's produced naturally in similar ways, such as carbon dioxide is, plant decomposition, animal digestion, etc. There are bacteria that live in swamps, for example, that produce methane as a byproduct of their digestion. However, methane has also, more than doubled since the Industrial Revolution, from 0.7 parts per million to, when I last checked, about 1.8 parts per million. However, it's a little bit easier to control. It has a lifespan of only 12 years. However, it does absorb more heat than carbon dioxide. Nitrous oxide, or N2O, is not as common as the previous ones, but it is much more powerful. It can absorb about 300 times the thermal energy that carbon dioxide can. We get nitrous oxide, N2O, produced naturally by some bacterial reactions in soil and water. But the main anthropogenic source, or the main human-caused source, is nitrogen-based fertilizers, which is used a lot in farming. A class of gases known as CFCs, or chlorofluorocarbons, are also known as greenhouse gases. Given the name, they're made up by carbons, chlorines, and fluorines. There are no natural sources of this, so any CFCs found in the atmosphere are all man-made. They're produced by coolants, so your refrigerator coolant or your air conditioner coolant. The concentration in the atmosphere is now declining, however, which is good. They've been kind of regulated a little bit more in industry. And they do have a relatively long atmospheric lifespan. So depending on the type of CFC, you're looking at 45 or 100 years. So finally, we're going to look at H2O and O3, so water and ozone. These are ones that we want in the atmosphere for obvious reasons, right? We need water, and ozone protects us. These are naturally occurring greenhouse gases. So we're going to talk more about this later, but water can undergo what's called a positive feedback loop. It is hard to measure O3 as the amount in the troposphere is rapidly changing, but again, O3 is important. It does kind of shield our planet from harmful radiations. If we just kind of take a look at some common gases, so let's look at nitrogen and oxygen, for example, right? Those are diatomic, N2O2, versus water, carbon dioxide, methane, and those are greenhouse gases. And so they, there are similarities and there are differences, but again, the focus on climate change and the rising global temperatures is these greenhouse gases that have been artificially pumped into our atmosphere.